In this video, I'm going to show you how Infoblox's cloud automation solutions can help transform the way businesses work today. The first thing we want to do is take a step back and revisit what exactly is cloud automation. We see that it is actually the combination of processes and tools that provide some sort of management and provisioning of cloud computing workloads. This is important because currently data centers are underutilized, they're difficult to manage. We see that they're not agile enough and they're difficult to automate because of the aging physical infrastructure. We also see that functions are usually duplicated redundantly. As a result, what most companies are doing today is moving and shifting their workloads into public and perhaps even private cloud environments. And what this does is allows them to virtualize their workloads, and by doing so can provide them with the ability to automate. They have also independent teams running perhaps with their own choice of orchestration tools or technologies, and therefore by doing so it provides them with the flexibility to use different cloud providers. We also see that their financial model has now transformed into a software as a service or an operational expense-driven financial model. There are reasons or good reasons to change. One such is because it allows them to focus on their core business. And by moving into a highly virtualized workload environment, it provides them with the ability to achieve better business agility with a faster time to market. It allows them to scale efficiently by leveraging different granular charging models and using only what they consume. But it also reduces their capital investment because now they're shifted to an OpEx payment system. So we see that the shifting business requirements in the market today is what drives cloud automation. The problem that most of them first run into, however, is a lack of centralized IP address management. We see that whilst you can have different teams having different choices of orchestration tools or systems, they also conversely have their own separate IP address management solution. Some still run on spreadsheets, some run on a different IPAM, custom IPAM database. Some, if they're using Azure or AWS, will utilize the IP management functions in their respective public clouds. What ends up happening is that all these IPAM databases are siloed. They don't talk to each other, and therefore it makes it very difficult to plan a consistent IP address schema. One solution that we've come up with is to provide this authoritative IPAM layer with REST API backend that any number of orchestration tools can speak towards, and we can then integrate with private and public cloud environments. So in this demo, what I'll show you first is around local API gateway failure and how we handle that. And what that means is we have a cloud management platform sitting in the bottom here, and it is trying to send API calls to a cloud platform appliance sitting in either data center. The authority is actually the grid master sitting here on the top left. We see that it can send an API call, and that cloud platform appliance will route the API call to the relevant authority. In this case, it is the grid master. However, if that cloud platform appliance fails, the cloud management platform can quite easily detect a timeout and send the API call to the second cloud platform appliance. It will then route the API to the correct authority. The other failure scenario that we can see or we can demonstrate is around the grid master failure itself. So the issue here is what happens is if the grid master itself is down. We can see that in the grid we can actually promote the grid master candidate, and so by doing so you're shifting the authority across to the other data center. And what then happens is your cloud management platform can still continue to operate as usual, sending API calls to either cloud platform appliance, who will then route it to the relevant IP address management authority. In this lab setup, we'll see that there is a grid master candidate, and then the things to note are the cloud platform appliances 1 and 2. So I'll start by simulating an orchestrator and sending an API call to the first cloud platform appliance, which is 192.168.0.155. We'll see that we are creating a machine1.acme.com name and searching for the next available IP address from this particular subnet, and we're attaching some extensible attributes such as the tenant IDs, cloud platform types, and so on. As we run that API call, it will send it to the cloud platform appliance, which will proxy it to the grid master. And if we go back to our data management tab, we check our DNS zone for acme.com. Sure enough, we see that a machine hostname is provisioned and attached to the next available IP, which is a .1 address. So let's now try and send a second API call, but this time we'll send it to the second cloud platform appliance, which is sitting on .159. As we do that, we see that it's successful as well, and if you refresh the zone screen, we'll see that that machine is also being provisioned properly. If we go to the Cloud tab, we'll see that it has split it according to engineering and sales. And if I then take a look at my virtual machines, we can see that indeed virtual machine 1 and 2 have been created with the relevant FQDNs. So the question now is, what happens if we then start to promote the gridmaster candidate in order to simulate a failure of the gridmaster? We do a set promote master command. Okay, after a few minutes we're back, and that we see that the gridmaster candidate has actually changed its icon to full green, indicating that it is actually the gridmaster after the following promotion. We still have the gridmaster, or the former gridmaster, as well as the two cloud platform appliances. Let's now try to send an API call again to both cloud platform appliances, just to see how it handles the API calls with a gridmaster candidate promotion. So we'll see here, we'll send the first API call to the first cloud platform appliance, and it's come back fine. And we'll do the second one as well. And this time send the API call to cloud platform appliance number 2. And we see that it's also come back successfully. If we then go to the data management tab and check out the DNS zones, we look at acme.com, we should find that machines 3 and 4 have indeed been created, and there's been no loss of service on the API calls. Okay, so it will essentially delegate and proxy the API calls to the correct authority. The second problem that we see is around legacy name servers hindering full automation capability. And what this means is this. Let's say we have some on-premise infrastructure with some server clients, a Microsoft DNS, and a cloud management platform. And on the right, we have 2 VPCs running in Amazon, and the cloud management platform wants to provision some instances, either in AWS or on-premise via some auto-provisioning scripts. The issue, however, is that the cloud management platform can't talk nicely to Microsoft DNS, for example, to get IP addressing, or even to insert DNS authority records in Microsoft. So what then ends up happening is that there is broken DNS resolution. These servers have no way of resolving or understanding how to get to the DNS, or how to resolve DNS names sitting in AWS. What then happens is a manual process. So you have DNS administrators then manually inserting the changes or creating the changes in Microsoft in order for those DNS resolutions to work. A solution that we've come up with is to actually insert an Infoblox DNS instance on-premise, and the cloud management platform can then go on its usual self to provision instances in AWS or on-premise. What it then does is talk via API to us. It can then ask for the next available IP, as well as inserting a DNS record in the authoritative zone, which is hosted in Microsoft. Infoblox here will run a Microsoft sync to actually push the changes via RPC into Microsoft. And in doing so, it provides full resolution across the enterprise. So these servers can then resolve what's sitting on AWS instances or AWS VPCs. Okay, what we see here is a list of DNS servers that Infoblox is synchronizing with. You have grid members listed on the top 4 here. But on the very last entry, we have a domain controller that's running DNS services called win-dc1.lab. This is the Microsoft server that we are synchronizing DNS records and zones with. If we take a look at our zone list, we see that there is a zone called jasper.com, which is hosted by the win-dc1.lab server. And if we go into that zone, we'll see there are a whole bunch of records that are essentially pulled from the Microsoft server itself. And just to prove that this is actually accurate and working properly, we can go into a remote terminal session window, and we can see that the jasper.com zone indeed has the records and zones as shown before. So what we will do now is send an API call to the Infoblox server, and what we'll do is send it to the gridmaster, and we'll attempt to create a test1.jasper.com record with this particular IP address. What we should see is that the API call will be accepted by the gridmaster, which will then push the call, the record to the Microsoft zone via API. So after we've done a refresh, we can see that the test1 record is indeed pushed out and exists in the Microsoft DNS server. What this actually demonstrates is that Infoblox is acting as a gateway. It's taking API calls from one side and pushing it out to the Microsoft DNS server via RPC. So the converse is actually true. If we delete this record from the Microsoft DNS manager, we should be able to go back into the zone, and as we do a refresh, we can see that the zone record has updated, and the test1 record no longer exists. So this shows bilateral synchronization both ways. The third problem we see is that VPCs in Amazon actually do not allow DNS resolution to cross their boundaries. In other words, you might run into a problem where you have two instances in these VPCs, and they actually cannot resolve host names across each VPC. Accordingly, these servers will then have no knowledge of those VPCs either. What Amazon does do, however, is provide the ability to publish public IP addresses and public DNS records. So what you could do is have servers actually go via the internet, but you have to then punch a hole and provide an internet gateway through these VPCs. That's not a very secure method of working. A better solution is to actually provision what's called a shared services VPC. In that VPC, you would place an Amazon Infoblox DNS instance, and what that does is actually extract Route 53 zone data via API, and it then pushes it out via grid replication onto other Infoblox DNS servers that are sitting on-premise. By doing so, you have then DNS visibility across both sides. What then happens is those instances within the VPCs can query the shared services DNS, and it can resolve each other. Accordingly, the service on-premise can also query for those instances on-premise and resolve accordingly. So this provides full DNS resolution regardless of where your instances lie. What we're demonstrating here is the ability for Infoblox to deploy in an AWS zone. So here in the grid members list, we see a AWS member. It's sitting on AWS, and that's its IP address. What that member is actually doing is extracting zones from Route 53. In particular, it's these two zones that it's extracting. It's denoted by 100.vpc.com as well as 200.vpc.com. And we see there that these are private zones, and their source is coming from Route 53 in Amazon. If we move on to the Amazon Route 53 console, we see that there are these two exact same zones in there. And if we drill down into one of those zones, you'll see that there's a record that's created here for linux.100.vpc.com. That's the IP address. So this is actually what Infoblox is synchronizing back into the grid. So as we add more records in here, it will actually automatically show up into Infoblox's DNS. So let's take a look then at what that looks like on the Infoblox side. It's pretty straightforward. we replace the name servers with ours and essentially distribute it to all Infoblox members that you choose to. So here's that record there. So this comes into play, for example, here when I've got two consoles. The top one is an instance running on the 100 VPC, and the bottom one is an instance running on the 200 VPC. So what we'll see is that if we try to do a resolution for the other VPC, you'll see that it's an NX domain, and that's because instances from the 100 VPC cannot resolve outside of its own VPC. And the same thing will happen here as well if I try to resolve from a different VPC. You'll see that we get an NX domain. However, one solution is to deploy an Infoblox instance that is synchronizing those exact zones, zone data from Route 53. And so we will then point our DNS at that member and essentially resolve. And we can see that there is no error, and that's the record that comes back. Same thing happens on the other VPC. We get no error, so the full resolution is happening. And even if I go onto an on-premise machine, so let's just say on this particular instance, we're then querying the gridmaster in this case. There's no problems there as well. So there's full resolution enterprise-wide regardless of where you're sitting. So this shows how we can essentially propagate zones or download zones from Route 53 and propagate them enterprise-wide. So in summary, we see that Infoblox's cloud automation helps by providing a consistent, authoritative IPAM solution. This works across the entire enterprise, regardless of where your instances are located or whether or not you run hybrid cloud environments. We also seen that we provide a fully resilient, scalable, RESTful API processing layer. And this allows us to automate IP DNS assignments for all types of workloads. We've also seen that we can bridge the automation gap with Microsoft DNS via our Microsoft Sync feature. And this then also can provide enterprise-wide DNS resolution and solve some of the Route 53 limitations around DNS resolution across VPCs. We have compatibility with AWS and Azure public clouds. We also have compatibility within private cloud automation solutions such as VRA, Microsoft SCVMM, OpenStack, and Docker. Lastly, we provide full reporting and analytics around the virtual machine workload usage and trends. And this is useful if you wanted to break down usage around tenants or VPCs or virtual networks and so on. We see that there are real business benefits to a cloud automation solution from Infoblox. For one, it provides security and audit compliance. This is because we can provide central visibility of all workloads regardless of where they're located. This also reduces management costs because we provide a tool that can provide consistent and efficient orchestration via APIs. Your investment is also future-proof because we work across multi-cloud and hybrid cloud environments. The list of supported environments is also growing. And lastly, we provide a better user experience through the accurate, consistent assignment of IP and DNS.